So in the previous video, we saw what a output voltage might look like, right? So if we had a voltage controlled oscillator, we saw that this is the sinusoid that we could expect to come out, right? We have something that is changing based on the VCO free running frequency and then some output phase. So what if we had some ideal input to our system, not to the VCO, but some other ideal input, some received signal. So let's base that ideal input signal and let's express it in terms of that same free running frequency that our VCO has. So our system receives a signal, and it's a sinusoidal signal, and we can base the angle of this off of the VCO free running frequency plus some input phase. Now this input phase, or this input sinusoidal function, could have some other general frequency and some other general phase, psi t. So, right, we could also express it using as some general frequency and some general phase, where, right, this is not that close to what the VCO is, or it is not the same as what the VCO free running frequency is, and the phase may not match either. But if we could relate the ideal input phase to the free running frequency of our VCO. And so if we write our input phase as this difference between the phase, the frequency that we received and the free running frequency plus that phase, if we define that, then we could keep this same form, and we could rewrite the input sinusoid so that this input phase is based on whatever that received frequency is. And giving this ideal input, right, and some phase that we don't know, right, we could express this received signal in terms of the carrier frequency, and then the phase could be expressed in terms of the difference between the received frequency and the VCO frequency, and then some other amount of phase. So simplifying this even more, right, we remove those terms and we can now express our input, because these two things are going to cancel, right? We can express our input in two different ways. We can express our input as based on either some frequency that's not the same as our VCO frequency in a phase, psi t, or we can express our input as the VCO carrier frequency plus some input phase that is based on that other frequency that was received. Okay, so if we were then going to mix the VCO output and the received input, we can mix them together using two signals that have the same frequency out front. So they have the same frequency, but the phase is different. They each have different phase. And we express this input phase, right? This input phase is based off of the some other different frequency. And then this VCO output, right? This is going to be based, this phase was based off of another signal that we received from somewhere else.